I have posted this video to teach you how to do the last problem. Um, so one of the first things you need to do when you solve the last problem is you have to know how to draw a cooling curve. We know it's a cooling curve because the energy must be removed. Now, in order to help me draw the cooling curve, there are two things I should look at: the melting point and the boiling point. I know melting point is when a solid becomes a liquid, and a boiling point is when a liquid becomes a gas. So in order to draw my cooling curve, I need to have my axis drawn, and I do know that my temperature goes on my y-axis and my heat goes on my x-axis. Now, I'm looking at my melting point and I know it's 123 degrees Celsius. So I plotted 123 and I'm going to draw a flat line because I know melting takes place in the flat line. After that, I'm going to look at the boiling point. I know my boiling is a higher temperature, so I'm going to assume it's 20.2 degrees Celsius, and I'm going to draw a flat line further away because when it's boiling there is no temperature change. And now I am ready to complete my cooling curve. I draw my three slopes, and I know to label my three slopes. I know this is my gas, I know this slope is my liquid, and I know the bottommost one is the solid. And I know that going in the opposite direction, the gas is becoming a liquid. That means it's undergoing condensation on the flat line, and when it's going further down, the liquid is becoming a solid. So I would say it is freezing or solidifying. So those are the areas of change that I need to know. Now, so this substance is changing in its temperature from minus 30 to a negative 130 degrees Celsius. So that is the next thing that I'm interested in my problem. So I have to figure out where is my 30 degrees Celsius. So I'm just going to say that that starting point is my 30 degrees Celsius at which the substance is a gas, and now it's cooling down and it's coming down to a negative 130 degrees Celsius when it is becoming a solid. So now if you actually look at the graph, the substance is undergoing 5 different changes. Number 1, the gas is cooling down. Number 2, the gas is condensing. Number 3, the liquid is cooling down. Number 4, the liquid is freezing. And number 5, the solid is dropping in temperature. So there are 5 different calculations involved in this problem, and you have to solve them each individually using your equations and then add them up at the end. Now, we do know that along the slopes, the equation that is used is mCp delta T. But you have to be very careful about the Cp that you choose from this table. At this point, the substance is in its gas form, so you will choose the specific heat of the gas. When you come to the next slope, the equation is the same. It's mCp delta T, but now the substance is in the liquid phase, so you will choose the specific heat of the liquid. When you come down to the solid slope, again the equation is Q is equal to m times Cp times delta T, but now it's the specific heat of the solid. In your two flat regions, you will find that the equation you need to use is Q equals M times enthalpy of condensation, because in this flat line the gas is condensing. And remember, delta H condensation is the same as heat of vaporization, but it has a negative value. It's the one and the same numerically. Similarly, if you go down to the freezing flat line, the equation now is Q equals M times enthalpy of freezing or solidification. Remember that enthalpy of solidification and fusion are the same, but that the enthalpy is now negative because it's the opposite process. Heat is being released here. So now, having known which equations to use along those 5 regions, let's go ahead and solve those equations. So I'm trying to solve step 1, which is my gas cooling. And it's the slope. So therefore, my equation is Q equals M times Cp of the gas times delta T. Now, the mass of my substance is 15 grams. So I'm going to choose that. And now I'm going to the table to choose my specific heat. Cp means specific heat, but it is the specific heat of gas. So my specific heat of gas is 1.25 joules over grams degrees Celsius. Now, we have to look at the temperature change. If you look at the temperature change, the gas was originally at 30. It's at the bottom of that slope, and now it is at 20.2. We are only solving for that change in temperature. The final temperature is 20.2 and the initial temperature is 30.0. Remember, it is cooling, so it's dropping in temperature. Therefore, my final temperature is 20.2 minus my initial temperature is 30.0 degrees Celsius. So now I'm going to first subtract whatever is within my brackets, and if I subtract, I find that my temperature difference is actually negative. My temperature is, if I put it in a calculator, it's 20.2 minus 30.0. Therefore, it is minus 9.8 degrees Celsius. Now, if I multiply the 3 numbers, my final answer is negative 183.75 joules. I'm not looking at sig figs right now, but I'm going to round at the end. My answer units is in joules, and it's negative because my temperature change was negative. Now, let's go to step number 2. In step number 2, the gas is condensing. So my equation is Q equals M times enthalpy of condensation, which is M is the mass of the substance, 15.0 grams. And I know my enthalpy of condensation is negative enthalpy of vaporization. Only the sign changes. So the value is 0.59 joules per gram, but it is now negative. Negative 0.59 joules over gram. So if I multiply the two numbers, my final answer is negative 8.85 joules. Again, I'm not looking at sig figs. I'm just giving the answer on the calculator right now. And the answer is negative because the heat is being released. Now, coming down to step number 3, we see at step number 3 the liquid is cooling. And when the liquid is cooling, we have to use the equation Q equals m times Cp of the liquid times delta T. Now the mass of the substance is 15.0 grams times, I will go up to the table to look for the specific heat of the liquid. The specific heat of the liquid is 1.46 joules over grams degrees Celsius times. Now let's pay careful attention to the change in temperature. As it's cooling, the substance is at 20.2, that's the beginning temperature. And the final ending temperature of the substance is negative 123. That 20.2 is my initial and negative 123 is my final. And so therefore my temperature change should always be T final minus my T initial. So it's a negative 123 minus 20.2 degrees Celsius. So now if I multiply the three numbers, I get my calculator answer is negative 3136.08 joules. Now if you're wondering what is the negative 123 negative, you can put negative 123 on your calculator and subtract 20.2, and the difference actually is a negative 143.2. So if you would like to do that before you go into the final step, that is fine as well. But you should be able to get negative 3136.08 as you put it on your calculator. So we have solved for step number 3. Now let's go down to step number 4. At step number 4, we know that the liquid is now freezing and becoming a solid. Now it's a flat line. So step 4, the equation that I use is Q equals m times enthalpy of freezing or solidification. Now if I go up, I know the mass is 15.0 grams and I have to substitute enthalpy of solidification. Enthalpy of solidification is the same as enthalpy of fusion, which is 0.35, but the only difference is it's now negative. So it's negative 0.35 joules over grams. And if I multiply and I get the answer, that is equal to negative 5.25 joules. My last and final step is the solid itself is freezing. So it's now a slope again. And so my equation for step 5 is Q equals m times Cp of the solid times my change in temperature. The mass of my substance remains 15 grams. Now I have to look for the specific heat of the solid, which is 2.02 joules over grams degrees Celsius times my change in temperature. I have to be careful as I look for the change in temperature. I know my beginning temperature is 123 and my final temperature is a negative 130. So I will do negative 123. Negative 130 is my final temperature minus my initial temperature is a negative 123. So it's negative of negative. So therefore this is negative 7. You can put it in your calculator to see that it's negative 7. So my math is 15.0 grams times 2.02 times 7 degrees Celsius. Again, I'm not looking at sig figs here and I'm just multiplying across and I get my answer to be negative 212.1 joules. So I've gone through all the 5 steps of calculating the heat change for each and every step. Throughout my answer is negative. So these are all the negative numbers that should be added in the last and final step, which is step 6. In order to calculate the total heat that is released when the substance is cooled, you just have to add all these numbers up. I'm just going to put my negative sign outside the bracket, and I'm just going to add up all my numbers. So it's a negative 183.75 plus 8.85 plus 3136.08 plus 5.25 plus 212.1 joules. Everything is in joules. So if I look at the numbers that are provided to me and the temperature change, I find that my minimum number of significant figures is 2. So when I add all these numbers, I get negative 3546 joules, and I'm just going to round it to 2 significant digits, which is 3500 joules. So that is my final answer. You have to go through all the steps in order to arrive at the final answer. I hope this explanation helps you understand the problem, and you will be able to do such a similar problem on your test.